Hi, my name's Anna and I'm a PLA for OChem 2, and something that I have realized is most overlooked by students is the formation of substitution and elimination products, because it was brought up in OChem 1 and a lot of students decided to kind of put that in the past and not bring it into OChem 2 because there's a lot of new material, but this is something that carries on with every test. And I have brought it up to a lot of students and shown them this chart that I'm about to show because I think as visual learners, there's a lot of visual learners in OChem 2, that this is a really important tool to just memorize and keep in your head. This is one of the most important things in synthesis, which is pretty tricky for me personally, but after I memorized this chart, because I personally am very visual, I found that it helped me through my success in OChem 2. So I'm just going to create this chart, and it's in terms of alkyl halides. So there are primaries, secondaries, and tertiaries, and the categories or the columns are going to be strong nucleophile, strong base, strong nucleophile, weak base, weak nucleophile, strong base, weak nucleophile, weak base. And with these columns and rows, the reactions or products that will be formed are E2, SN2. However, this will be the matrix product. E stands for elimination, S is substitution. The number 2 means that no carbocation is formed. If there's a 1, that means a carbocation has formed. Okay, so secondary will form E2, SN2, but E2 will be the major product. E2 for the tertiary. SN2, SN2, SN1, carbocation formation right there. This column will all be E2, elimination with no carbocation, and the last column will have SN2, SN1, or E1 with heat. The triangle means heat. It has to be present for an elimination to be formed. And then same thing for the last one with heat for E1. And let me draw in to show what kind of reagents we're talking about, like that'll be used to create the products. So for the first column, we're really looking at, alcohols, negative methoxides and such, and like negative alkynes. Second column, we're looking at halogens, like chlorine and bromine, or ammonia. Third column, this is like one of the most overlooked. This creates anti-Zaitsev, which is the least substituted carbon that creates an elimination or substitution. So this is like bulky bases. We see that this is like bulky in nature, or negative hydrogens, but this is like the main thing. And last column, we're just looking at like waters and methanol. Just like weak nucleophile, weak bases. So I'm going to give some examples to show what I'm talking about, because with different conditions, these will create different products which lead to different formations in synthesis. So it's important to recognize like what this chart really means. So let's start with the same alkyl halide. We're going to use this one, and this is a secondary. Same thing down here. Secondary, connected to carbons. Let's throw in this bulky base that we talked about. So bulky base, secondary alkyl halide, bulky base, secondary E2, elimination. Anti-Zaitsev, remember we talked about anti-Zaitsev, the least substituted, so the double bond would fall right here. For this one, sorry, I didn't mean to do that. For this one, let's say we throw in just an alcohol. So we have, let me get my laser. Alcohol, secondary. Alcohol, strong file, strong base, secondary, E2. However, this one's not anti-Zaitsev. Double bond will be on the most substituted. And let's say that the final product was an alcohol. So we're just going to do hydroboration, which is using 9-BBN. And this creates the least substituted alcohol. So in this case, it'll fall on this carbon right here. Let's do the same thing down here. least substituted alcohol. We really have two spots that are the same, so let's just put it here. And we see that with the same reagents right here, we get different products. And why do we get these different products? Because we have different starting materials, which were created from two different reagents, different conditions, but same starting product. But we have to recognize that there's different products for what we use. And that's why this chart is really handy. And let me just give one more example to just make it really clear. So if we start this tertiary, and we throw in water, tertiary, water, tertiary. No heat, so we're going to do SN1. Substitution. So an alcohol will be substituted for the bromine. Same starting material. Let's use water with heat. Water, heat, tertiary. Water, tertiary, heat. Elimination. Most substituted in this case. It'll be right there. So from this we see that even with the same reagents, under the condition of heat, it'll create different products. And these will lead to different products in synthesis. Like you could do something with this, where this can't in that case.